Choice of file system for GNU/Linux on an SD card. I have an embedded ARM-based system running on an SD card. It's currently Debian GNU/Linux using X3 as file system. As I'm about to reinstall the system, I started wondering about changing to a more flash-friendly file system. I've heard about JFFS2, YAFS2 and LOGFS, and they all seem suited to the job. Which one would you recommend? Also, I've heard there have been a lot of Ext4 improvements to better suit SSD disks. Am I to interpret that as running Ext4 should be just fine? What do I need to think especially about in that case? I guess the usage of the system is important. But for the sake of generality, imagine it'll do standard desktop stuff, even though it is in fact a small ARM-based system. Thanks for any replies. Edit, Wikipedia tells me, in a citation needed statement, that removable flash memory cards and USB flash drives have built-in controllers to perform wear leveling and error correction, so use of a specific flash file system does not add any benefit. Thus, I'm leaning towards sticking with an Ext file system.
Excellent article about flash file systems. Important question when talking about flash file systems is following. What is wear leveling? Wikipedia article. Basically, on flash disks you can write limited number of times until block goes bad. After that, file system, if there is no built-in wear leveling management on hardware, as in case of SSDs there usually is, must mark that block as invalid, and avoid using it anymore. Typical file systems, for example RACERFs, NTFS, X3 and so on, are designed for hard disks that do not have such limitations. JFFS2 includes compression and elegant wear leveling protection. YAFS2 single thing that makes the difference, short mount times, after successful mount. Implements write once property. Once data is written to one block, there is no need to rewrite it. This is important, as it reduces wear. LOGFS. Not very mature, but already included in Linux kernel tree. Supports larger file systems than JFFS2/YAFS2 without problems. UBIFs. More mature than LOGFS. Write caching support. On scalability, article. On large disks, better performance than with JFFS2. Ext4. If no driver or card, for example SSD drives do have internal wear leveling, at least usually, handle wear leveling, then Ext4 is not the best idea, as it is not intended for raw flash usage. Which one is the best? Of course, it depends on usage and support. From what I read on the internet, I would recommend UBIFs. Good support for large file systems, mature development phase, adequate performance and no huge downsides.
I was facing the same problem and did some research as well. Eventually I decided to go with X2. It seems that some SDHC cards implement their own wear leveling at the hardware layer. If you can get hold of SDHC cards that have wear leveling built in, file systems that provide wear leveling can interfere with the flash level wear leveling, so it can actually be bad for the flash to use them. The IBM article cited above talks about how JFFS does it, so it's clear that that won't work with flash level WL. I decided I didn't need Ext3's journaling since I'm not storing critical data on it and I usually back up regularly anyway, cron. I also mounted /tmp and /var as tmpfs to speed things up. If you have enough RAM you should do that, but be sure to rotate or delete your logs regularly. Hint: mount your SD cards with the no time option.
Selecting and sizing the correct file system is more important than anything else, not only for security but for tons of other reasons people do not usually recognize. Without a file system, all processing would go to null. Very well put response by Ollie, and the op is much dated, but file systems are my pet peeve. I could not stay away. Superuser.com is not something I visited before. I am not an admin, but I signed up and I am going to visit more. Things changed a lot since 2011, but even back then I formatted USB cards FAT, and used USB drives to carry 4 GB plus files around. The reason of course was compatibility, not security, so much for SNSD, but I use passwords on my 7Zs, and I never really carried anything bigger than a CD ISO. They were mostly for SQL scripts and daily hourly diffs of already encrypted database snapshots squeezed to near death by 7-zip. These days I wear any SD out faster than anyone I know. I have a USB stick in some production machines at my employer for hourly automated backup, formatted FAT. I keep an eye on them every day though and, you guessed, back them up religiously by hand. They are offline secured building ETAR stuff. SSD leveled some of the playing field, but I still do not trust them as much as regular HD, and SD is worse than optical. They go bad in an instant and the loss is total. Any file system which invites the host OS to write randomly to it, NTFS, recycle bin, is bad news for an SD. Also, unmounting it helps a lot. No OS is going try accessing unmounted storage, so any file system will do as long as the SD includes a script to unmount itself, one of the standard files on every SD online. Reading an SD is still slow today, so I would recommend something like disk dump, DD, to grab the entire image when mirroring instead of file by file. DD also let you know when there is something wrong, so your file manager won't go kaboom. Of course, if your primary purpose is to extend the life of some penny stock, you are going about your business the wrong way. I do what I do not for extending the life of an SD but to keep it from going bad when I am not watching, and there is the difference. I avoid X4 or any journaling FS on SD because I do not care when they go bad writing to them, but it sure hurts when a day or so later I cannot read them.
I don't know if this fits into your system's profile, but what about using a read-only file system plus a read-write partition, or a USB stick that can be replaced easily? That way you'll have a fast disk for your OS and can replace your RW storage easily when it wears out. And then there's UNIFs. As I understood it, it stacks different file systems, i.e. a row Fs on top of a RWFs. If there's a read access, UNIF seeks through th stack until it hits the Fs containing the file we search for. When writing UNIF, search for the first writable Fs on the stack and uses it. I also found these articles that may be interesting. This URL. And 2 articles with tips for using SSDs, this URL.
Ele bate você pode também e lá se consiga subscrever.